All right, we're going to get started with practice exercise number 23 there at the bottom of page 20. So go and turn in your speed drill and review exercise book to page 20, exercise 23. Quick review from last time. We talked about car insurance, right? And in your own words, what's the point of car insurance, Joshua?
Just in case your car gets crashed or you get in an accident that you don't have to pay all the money.
There we go. You get in some sort of accident, something bad happens to your car, you don't have to pay a whole bunch of money. Now, there's three types of car insurance, Lana, that we talked about. There's one kind you absolutely have to have required by law because if you hit somebody, you have to be able to take care of them. And most human beings don't have enough money for that. So you have to have, do you remember? If it's your fault, you are guilty. There's another word that means guilty. You are, do you remember without looking?
No. Liable?
Liable. You are liable. So do you remember what kind of insurance we have? Liability insurance. There we go. So liability insurance you have to have. That covers the other guy. All right? It covers everything for the other guy. It covers his vehicle damages. It covers personal injury. Most insurance will have what's called a 100-300 tier, where they'll pay up to $100,000 worth of damage. That's in case you hit a Lamborghini. Don't hit the Lamborghini. Your insurance ratio goes so high. Okay, but also $300,000 worth of coverage for medical expenses. Now, if the other person's medical expenses go over that, that's where you get sued personally. But usually most medical expenses won't go over $300,000. Okay, so you got that coverage. Now there's another type of insurance in case you want to get your own car fixed up when you cause the accident.
Policyholder?
Well, the policyholder, that's the guy who owns the insurance policy. So to cover the policyholder's own vehicle, in case he's the one that causes the collision, we have
I know it's supposed to be C.
collision insurance. I sneaked that in there. Okay, collision insurance covers your own car. That fix up any of the problems you have. Now, there's also something that can be worked in there called MedPay that will also cover your personal injury. Usually that's pretty low. But that's not something we talked about here. Usually, if you get hurt, it's your own fault. You got to pay for your own medical expenses. Your health insurance may help to cover things like that, but mainly it's your fault. You got to get that taken care of. Sometimes, though, it's not a car accident, right? It's other things, right? A tornado picks your car up and throws it 2 counties over, and it's a mangled wreck. Now what? Well, for tornadoes and hailstorms and people with baseball bats and, just people in bad moods who, bust up your car because they feel like it. My parents, for instance, their car was being worked on at an auto shop. I remember I was 6 years old. I was about to turn 6. And the car was having problems. It's a really old, messed up car. Sitting outside the car insurance, the auto dealer, they were working on some things. And a guy apparently broke into my dad's car to steal some money. Well, he didn't find much money because we were poor. All he found was a little bit of change. He got mad and he flipped his cigarette into the car and it burned up. So we didn't have a car. And so we had insurance, paid for a little bit of the value of the car. It didn't buy us a new car, but it paid for the value of the car, whatever was left of that thing. And probably a few $1,000s back then. This was, over 25 years ago. But anyway, long time. But what kind of insurance would cover that? What kind of policy? Either of you?
No,
comprehensive insurance would cover the policyholder's car in case of some non-accident related damage. Now, it doesn't necessarily, unless it's totaled out like my dad's burned up car, but unless it's totaled out, okay, you pay for a certain amount if you're at fault. Or it's just, tree falls on your car. Okay, you pay for the first amount. Maybe it's $500, maybe it's $1,000, maybe it's a couple $1,000s. What do we call that upfront amount you have to pay before insurance will cover the rest?
Deductible.
Good, the deductible, right? So you pay the deductible, they pay everything after that. That's what we're looking at here with just 2 problems, though the first problem has several parts to it. Exercise 23, there at the bottom of page 20. Go ahead and get started.
Exercise 22, right?
It's okay. Exercise 23, there at the bottom of page 20. The sharp family. All right, let's go and take a look at this exercise together. Joshua's first. Joshua says the Sharp family has paid $120 each month for auto insurance the past 2 years. Mr. Sharp caused an accident that cost $7,855 in damages and $8,920 in health care. That's actually really low for health care, pretty high for damages. His deductible is $1,000. Question number 1, how much has he spent on auto insurance over the past 2 years?
$240.
Lana?
$2,880.
Not at 120 a year, 120 a month. So not times 2, but times 24, right? 2 years, 24 months. So $2,880 should have been our answer. Lana, let's go to you then. How much will the insurance company pay for the accident that he caused?
$15,775.
Good. We add up the damages and the health care, but we subtract 1,000 of that because he's paying that, right? So we'll add them together to get, what is that, 16,775? But minus the 1,000 he pays of that, the insurance company's going to pay 15,775. All right, so question, how much did the Sharps save by having auto insurance?
$12,895.
Good, because the company paid $15,775 minus the fact that they had already paid the company $2,880. They still saved $12,895, which again, on the surface, you pay $120 a month. You're like, man, paying all this money to the insurance company. Well, as soon as you get it, as soon as you cause an accident, it's going to be worth it. Now, I've been driving for almost 11 years now, paying insurance premiums for almost 11 years now. I've never caused an accident. But statistically speaking, eventually it's going to happen, right? And when it does, boy, am I going to be thankful that I had insurance. Okay, in the long run, I'm sure it'll save me, bless you, some money. So $12,895 is our answer there for number 3. Now, the next problem says after the accident, because here's how it goes, the insurance company raised the Sharps' monthly premiums to $148. Oh, you caused an accident? Well, now we're going to stick it to you. Really, $148 is still not that bad. But what is the percent of increase, Lana, to the nearest tenth of a percent?
23%.
Nearest tenth of a percent. So 23.3%. Right, the 3's would repeat. So 23.3%, I'll give it to you. Percent increase. Again, change 28 over original 120 would give it to you 0.233333 or 23.3 repeating percent. Joshua, your answers would have been different for number 3. Did you get number 2 correct?
Yes.
Okay, and so you would have had a much different answer though on part 3 because you had a different answer on part 1, right? Okay, what about the last problem, the percent of increase? Did you get that correct? Okay, good. All right, any questions on those at all? All right, let me go and collect those from you. And if you would, go and turn in your textbooks to page 140, or not 140, I'm dyslexic. I got all the right numbers, 401. Let's try 401. Let's take those 3 digits and change up the order there. Page 401. In your textbooks. And you did numbers 1 through 17. 1 through 17 here on page 401. Working with probabilities, lots and lots of probabilities. I have a good summary, really, of all the different probabilities we've been working on this whole time. Number 1 through number 6, you're just writing out the probabilities and probability notation. So number 1, if red or purple are mutually exclusive, how would I find the probability of somebody picking a red something or purple something? Joshua?
P red plus P purple.
Good, P red plus P purple. Now, if somehow red and purple could overlap, you'd have to also subtract the probability of both, but they're mutually exclusive. What about number 2? If these are independent events, the probability of run and the probability of bike. Probability of run and bike. Lana?
P run times P bike.
Good. The probability that someone would run and someone else would bike, or that you would run and bike, would be probability of run times probability of bike. Now, number 3, if these are dependent, probability of door and window. That means probability of door, and then after door's taken care of, also doing window. Okay? So what would that be for number 3? Joshua?
P door times P window after door.
Good. P door times P window after door. How about number 4? P house and condo independent, Lana?
P house times P condo.
Good. P house times P condo. Number 5, let's stay with Lana. Probability of sweater or jacket mutually exclusive.
P sweater plus P jacket.
Good. What if they weren't mutually exclusive, Joshua? Just throwing that out there.
P sweater plus P jacket
minus P both. There we go. And number 6, Joshua, dependent, probability of noun and verb.
P P noun times P verb after noun.
Good. P noun times P verb after noun. Good. Questions on all that probability notation. All right. Now into the actual problems. 2 jars hold 5 marbles each. Jar A has 3 red, 1 blue, 1 green. Jar B has 3 blue, 2 red. What is the probability of picking, number 7, a blue or green from jar A? First of all, what will we do? Add or multiply, Josh?
Add.
We will add, and when you added, you got? 2 to 5. 2 to 5 probability, or 2/5 is fine. Number 8, how about a red from each jar? Lana, will we add or multiply? Multiply, because red from each jar means a red and then another red. So we would have to multiply. And what did you get for your answer?
6 to 25.
Good, I forgot to ask, is that dependent or independent?
Independent.
Independent, because the 2 jars don't affect each other. So independent, 6 to 25 is correct. Number 9, 2 reds from jar A without replacing between draws. Do we multiply or add here, Josh?
Multiply.
We will multiply. Independent or dependent?
Dependent.
Dependent, because if you don't replace, then the first draw is going to mess up the second draw, or affect the second draw at least. So what's the probability?
3 to 10.
3 to 10. Excellent. Number 10, a blue from jar B, replacing it, and then drawing a red, presumably also from jar B. Add or multiply, Lana?
Multiply.
Multiply, dependent or independent?
Independent.
Independent, because you replace the first, the probability is
6 to 25.
6 to 25. Number 11, blue or red from jar B. Joshua, add or multiply?
Add.
Add. These are mutually exclusive. That which is blue is not red. And what's the probability?
3 to 5.
Lana?
I got 1.
1 to 1. That's all that's in jar B. So you know you're going to get blue or red. It's like reaching into a jar with nothing but blue and red. You're like, ooh, I hope it's blue or red. Well, good news. That's all that's in there. So you're guaranteed to be happy. So 1.
Oh.
Right? All right. Other than number 11, were there questions on any of the others? 7 through 10?
On number 7, are you sure it's 2 to 5?
Well, let's take a look at it. That's what... Did you say 2 to 5? I thought
I said 2 to 5.
But now you're questioning?
Yeah.
All right, so let's take a look. Blue from jar A. So probability of blue, and then it says or, so plus the probability of green. Well, in jar A, there is 1 blue out of 5, plus there is 1 green out of 5. So when you add 1 to 5 and 1 to 5, it does give you 2 to 5.
Would it like go down since you're taking it from the same jar?
Oh, no, it's not taking this and this, remember.
Oh,
Right. It's taking either one of them. It's like, I just want a blue or a green one, right? So of the 5, how many are blue or green? 2 of them
Yeah.
are. So that's why it's 2 to 5.
Okay.
Yeah, so that's the key is or. Now, and would be totally different, right? If it were and, number 1, we'd multiply, and it'd be after blue, which would be 1 to 4 now, which would multiply to give you a 1 to 20 chance of pulling first blue and then green. Yep, good question. Good. Any other questions, 7 through 11? All right, let's take a look at numbers 12 through 17. Lana, if you'll read the main part of the problem for us.
Each of the 9 letters of the word following is written on a separate piece of paper and placed in a hat. What is the probability of randomly drawing an F and then an O if the F is replaced?
All right, so would we add or multiply here, Lana?
You would multiply.
Multiply, because it says and. Are these independent or dependent, Joshua?
They are independent.
Independent, because you're replacing the F. What's the probability, Lana?
2 to 81.
2 to 81 is correct. Number 13, probability of drawing a consonant or a vowel. Will we add or multiply, Josh? Add, and what is the probability?
2 to 9.
Oh.
I think I tried to multiply.
Lana?
It should be 1.
Should be 1. Everything's either a consonant or a vowel. It got you again. That's why I came back to you on that one. Yeah, 1. You're guaranteed a consonant or a vowel, right? There are, or if you want to do the mathy way, right? There are 1, 2, 3, 4, 5, 6 out of 9 consonants, and there are 3 out of 9 vowels, which gives you a probability of 9 out of 9. You multiplied again, which gave you 18 to 81 reduces to 2 to 9. That's what happened. Yes, you recognize they were all consonants or vowels. Now, if it had been consonant, then vowel with replacement, now it's 2 to 9. Okay. Number 14. An L and then a G if the L is not replaced. Do we add or multiply, Lana?
Multiply.
Dependent or independent, Joshua?
Dependent.
Dependent this time. What's the probability, Josh?
2 to 72.
Reduce it down. Divide both of those by 2 to get?
1 to 31? Wait.
36, carry the 1, right? So it's dividing into the 12 instead of the 2. Yeah, 1 to 36 should have been our answer there. Number 15, an L and then an O if the L is replaced. Add or multiply, Josh?
Multiply.
Multiply. Dependent or independent, Lana? Independent, because we got the replacement going on. So Joshua, our probability is?
4 to 81.
4 to 81. Number 16, 2 vowels. If the first vowel is not replaced, add or multiply, Lana?
Multiply.
Dependent or independent, Lana?
Independent.
Dependent. So what's the probability?
1 to 12.
1 to 12. Number 17, an N or an O, Joshua, add or multiply? Add. Obviously, these are mutually exclusive. That which is N is not O. So what do we get for our probability? 1 to 3 is correct. Any questions? 12 through 17.
I just forgot to reduce, and on some of them I didn't realize.
Okay, questions at all on that? Now, the one thing we didn't get a chance to practice with were not mutually exclusive, right? That wasn't in the homework. So I want you to picture for just a moment a spinner, and I'm going to see if I can draw this effectively. I don't make any guarantees, but let's suppose, for sake of argument, that there are, pretend these are all evenly spaced sections. They're obviously not 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Horrible job at drawing them evenly. Let's suppose they were evenly and I wanted to hit a spinner around here. Okay? What's the probability of getting an even number or a perfect square? Now remind me, what's a perfect square, Lana? What does that mean? Perfect square. Do you remember from last year? What's a perfect square? Josh, help her.
Like a square of a number? But
The square of some other number, right? Or something you could take the square root of easily. Like if 64 were on here, you can take the square root of 64, right?
Oh.
You could take the square root of, you can't take the square root of 2.
No.
You can take the square root of 4. Okay, what else?
6.
Can't take the square root of 6.
Wait.
So 4 would be a square. 64 would be a square because like 2 squared is 4, 8 squared is 64. What's another number that's a square?
25.
25 would be a square because 5 squared is 25. What's another number that'd be a square?
36.
36 would be a square.
49.
49 would be a square. Let's fill in some squares down smaller because we want some numbers that'll be on the spinner.
Is 8.
No, because
9.
nothing squared gives 8.
There's
Oh.
9.
9. Okay, 9 would be a square because 3 squared is 9.
Yeah. That on the spinner.
Well, maybe. Obviously 16, right? That'd be 4
Yeah.
squared. What about 1 squared?
1.
That's just 1.
Ah, that's on the spinner,
Oh.
right? Okay, so what's the probability of picking an even number or a perfect square? Well, how many numbers are even, class?
5.
5 out of
10.
10. And since it says or, we're going to add. How many perfect squares are on the spinner?
3.
3
Yeah.
perfect squares are on the spinner out of
10.
10. But are there any perfect squares that are also even?
Yes,
4.
there's 1.
Yes, the number 4, right? So we have to subtract away the both, right? Which would be
1 to 10.
1 to 10. So what's the probability of an even number or a perfect square?
9 to 10.
Ooh.
Wait,
7
5
plus.
5 plus 3 minus 1.
Wait, where do you get the
5
1
plus
to 10?
3 is
The number 4 is
minus
both.
1 is
Oh, I
4
was
is both a
thinking that.
square and an even.
I was
So
thinking 4 to 10.
not 4 to 10, 1 to 10. 4 is the one number that categorizes both. Do you remember going over this?
Yeah.
This was in that level up section, which is why the book doesn't have it here. Okay, let me give you another example with the spinner here. Let's suppose I wanted, let's say, a prime number or an odd number. A prime number or an odd number. What are our prime numbers anyway?
2,
2,
3,
5,
7.
9.
No, not.
Wait, oh, not 9. Just
Yeah, that's it.
11. 13.
Right, so obviously not prime numbers keep going and going, but of the prime numbers, so what's the probability of prime?
4 to 10.
Okay, and since it says or, we're going to,
Half.
how many odd numbers?
4 to
5.
10. Wait,
it
1, 3,
1, 3, 5, 7, 9.
5.
Right, half of them literally are odd, right? Half will be
Yeah.
even, half will be odd. But how many are both prime and odd?
3.
3 of them, 3, 5, 7, right? So 3 to 10 are both and have to be subtracted away. So what's the probability of prime or odd?
6 to 10, which
10,
reduces to
3 to
3 to 5.
There we go. Makes sense for you to remember doing this.
Yeah.
Let me give you one more. What's the probability of a number that is greater than 7 or that is even? A number that's greater than 7 or is even. Do it at your seats. Greater than 7 or even. Again, assuming these were all equal areas. Okay, if they're not equal areas, that totally messes it up, right? You ever played where there's one section of a spinner that's bigger than another? I've played a couple games like that where certain sections are bigger than others because they want you to statistically hit that other section more often. But assuming equal areas. All right, probability of greater than 7, class?
3 to 10.
3 to 10. 8, 9, and 10 are the only numbers greater than 7. Plus even.
5 to 10.
How many are both greater than 7 and even at the same time?
2 to 10.
2 to 10. So our answer is
3 to 5.
6 to 10 or 3 to 5. Questions on not mutually exclusive. Okay, want to take a chance to review over this again. Any questions here? All right. We'll go across the page now at page 400. Page 400, I want you to do numbers 19 through 21. Page 400, do numbers 19 through 21. By the way, those squares we talked about, we're going to look at a lot of those as we get into the fourth quarter material. We'll do a lot more with squares. Page 400, just right across the page from where you were, numbers 19 through 21. It's a little set of questions. And for sake of time, I don't need you to answer anything but just actually find the probability. At this point, I think you know how to identify whether it's dependent or independent, multiply or add. Just do it, okay? For sake of time. On number 21, it doesn't say the solid shirt is thrown back in. Solid and then polka dot. These would be dependent. All right, let's check. On number 19, it would help to have my book. We wanted striped shirt and red box. Okay, the shirt and box don't affect each other at all, right? Those are independent. Striped shirt, 4 out of 40. And we multiply red box. There's only 2 out of 30. Do some canceling. 2 with the 40, or the 4 with the 40, and the 2 with the 10, all that. End up getting 1 to 150. Did we get that? 1 to 150. On the next one, it said a green or orange box. Okay, so or means we're going to add. There's 10 green, there's 4 orange, 14 to 30, or 7 to 15. And then on the next one, it said a solid shirt. Well, that's 6 out of 40. And then a polka dotted shirt. Well, assuming we didn't replace the solid shirt, there's 24 out of now 39 shirts still left, right? A lot of canceling to do there. I did the 24 and 40, took an 8 out of both of them to get 3 and 5. And then 3 and 13 could cancel, or 3 and 39 could cancel, you get 1 and 13. End up with 6 to 65 on this one.
I was about to get that.
About to get
I
that?
was about to get that. I just said.
All right, does it make sense? We good to go? All right, moving quickly for sake of time. Let's take a look at 22 to 24 now. 22 to 24. I'll tell you what, for sake of time, first of all, let's find how many paper clips are in there. How many paper clips are in there?
45.
45 paper clips. All right, that's going to be important to keep that number in mind. So, what's the probability of green, then gold, without replacing green? Find it quickly. Probability of green, then gold, no replacement. Well, what's the probability just of green, class?
5 to 45.
And means we're going to? And if there's no replacement, there's not 45 clips anymore, where there's now?
39.
Ooh.
I meant 44.
44. You were thinking of the last problem. And how many of those are gold?
2.
I've got 2 gold.
Wait, what?
Says there's 2 gold paper clips, right?
Oh, I was thinking something else.
All right. We can do a little reducing, right? 5 and 45 reduces to give us?
1 and 9.
And 2 and 44 reduce to give us?
Oh. 1 and 22.
So what's the probability of green, then gold without replacing? Go Irish.
1, 2.
198.
Good. 1 to 190. It would take 200 tries before you get back to that green and gold almost. What about black or aqua? Black or aqua. What's the probability of black, class?
15 to 45.
Thank you, Joshua. When it says or, Lana, we know we need 2. And then how many aqua, Lana?
3 and 45.
So what's the probability, class?
18
to 45.
Which we can divide both of these by a 3 to get. Actually,
6 to
we can divide by 9. Let's divide by 9. I'm sorry.
9. I was 2
2
to
to
5.
5.
There we go, 2 to 5. Yeah, sorry, I was saying, well, we at least have a 3. Wait, we got a 9 in there. Let's get that 9 out. All right, here's a fun one. Silver and then black if silver is replaced. What's the probability of silver, anyone?
20 to 45.
Now, if we replace the silver, there's still
45.
45. By the way, it says and, so we're going to multiply. How many still black, excuse me?
15 to 45.
15 to still 45. Let's reduce by 5 here.
4 to 9.
And let's reduce by 15 here.
1
to
4.
5.
3. Remember,
Wait,
3
three,
15-minute sections on a clock.
Yeah.
So what's the probability of silver then black?
4 to 27.
Good. 4 to 27, assuming you replace the silver that you already pulled out.
Yeah.
Questions on that? All right. Tell you what, let's skip over 25 to 27 for sake of time right now. And let's go over to 28 through 30. 28 through 30. Music people. Here you go, Lana. Do you know anything about music, Josh?
Nope.
Just make it up as you go. All right. So, Lana, this is for you. Flashcards with 5 whole notes, 6 half notes, 2 quarter notes, 10 eighth notes, 3 whole rests, and 4 time signatures. What's the... Well, first of all, how many cards did she make? Let's find it. Okay, the good news is you don't have to know anything about music to figure out how many flashcards.
26. Wait, no, 30.
Yeah, I got 30.
Yeah.
30? All right, so 30 cards. All right. What's the probability of picking a quarter note?
2 to 30.
2 to 30. And so we need to
Multiply.
a whole rest if the card is replaced. So if it is replaced, we still have
3 to 30.
30, and you said whole rest was 3 to 30?
Yeah.
All right. And we could reduce a little bit here, the 2 and 30 to get,
1 and
1,
15.
the 3 and 30 to get.
10 and
1
1.
to 10.
So our probability,
1, 2,
1
1.
to 150.
do you see how to attack these? Just bam, bam, bam. Okay, attacking quickly. What about half note?
6 to 30.
6 to 30, 3 to 6 to 30, good. And
And
so we need to multiply it. But it says without replacing it, so my total options come down to
29.
29 cards. And it says time signature,
4 to 29.
4 to 29. Let's reduce the 6 and 30 to get.
1 to 5.
And nothing else cancels, so we get.
1 to.
Ooh,
4
careful.
to.
Wait, oh, 4 to.
Good, Scott, 145.
What?
I could hear it. All right. I could hear him saying it over the video. I have telepathy. All right, 4 to 145 is correct. All right, how about an eighth note? Good, 10 to 30, Scott. Good. Don't reduce it to 1 to 3 yet. I know you want to. And this is or. Or means add.
Add.
By the way, that's why you don't want to reduce it to 1 to 3, Scott, because when you add, you're going to want that common denominator. Whole note.
5 to
5.
5 to 30. What's the probability?
15 to 30, which is 1 to 2.
Ah, there we go. I think Josh got you that time. 1 to 2 is correct. All right, I'm making it up.
Yeah.
I'm faking. But anyway, just picking on Scott even though he's not here because it's what we got to do. All right, and maybe picking on Lana just a little bit there, messing with her mind.
Yeah.
All right, questions at all on probabilities?
No.
All right, well, clear your desk except for clean sheet of paper and a pencil. Clean sheet of paper and a pencil, everything else away. I'm going to write the homework on the chalkboard, so when you're finished with your quiz, you can copy it down. Scott, you'll, of course, end the video, and you can just leave the homework assignment written on the board. But to clear your desk except for clean sheet of paper and a pencil, and let's take a quiz over all things probability.
Is it just the brightness?
You're going to make 100 on this, man. You're going to do great. I find your lack of faith disturbing. All right. All right. Quiz 29 and Quiz V. They're kind of attached together a little bit. Notice on Quiz V, which is your second page, the first 6 have been crossed out. So we're just going to do Quiz 29 and then the last part of Quiz V. So we get all the different probabilities worked in here. First and last name at the top of your paper, along with today's date, which is 2/22/21. 2/22/21, today's date. The upside of adding Quiz V to the backside, number one, I get to review it via quiz, but also it lowers point values. They're not worth as much now, so that helps. All right, should be pretty straightforward. Go ahead and get started, and we'll end the video here once I've got the homework on the board. Think about it. If something can't be this and this at the same time, then those things must be